But for now, I'll turn it over to Erik Nielsen from the School of Earth and Sustainability at Northern Arizona University.
Thank you very much, Kate, and thanks to Bryan and Ben for joining us on this really exciting panel. I think around 20 universities in the United States are currently utilizing biomass for heat or power or both. And you know, in the United States, about 5% of our energy comes from biomass, and it's about 10% globally. So we're somewhat underutilizing a biomass renewable energy resource. And we've got two innovators here to share some of their experiences. And so what I'd like to do is just introduce the two, Ben Fish from University of Iowa and Bryan Hermann from the University of Minnesota Morris, and invite you to tell us a little bit about your role. And if you could kind of kick off, talk about how you've utilized biomass energy technologies to lower your carbon emissions. So Bryan, do you want to start?
Certainly, thank you. My name is Bryan Hermann. I serve as Vice Chancellor of Finance and Facilities at the University of Minnesota Morris. And just 2 points of background. Just the University of Minnesota is part of the University of Minnesota system, and we are about a 1,400 student liberal arts campus on the western side of Minnesota. We are carbon neutral on the electricity side. We have two 1.65 megawatt wind turbines and about 260 kilowatts of solar, and we achieved carbon neutrality this last year. So on the electricity side. On the thermal side, because as Ben is in the Midwest as well, it's a little bit harder on the thermal side. We have a biomass gasification plant that would love to talk a little bit more about the bumpy road that we've been on it. It is, we're just about ready to fire it back up. So.
And I am Ben Fish. I'm with the University of Iowa, and our path started back in 2003. And I was lucky enough to come to the University of Iowa shortly after that. So I've been around for most of our trials and errors along the way in biomass. And it started in 2003 when a local manufacturing facility started working with the university because they had a byproduct item that they had lost a market for and wondered if we might be able to use that as a fuel. And we were crazy enough at the time to try that. And lo and behold, after a lot of work, it ended up becoming very successful. And sort of our path continued from there. Unfortunately, I think as I look back to my first few years at the university, I think we maybe spent a little too much time patting ourselves on the back because we were burning that product and maybe not focusing enough on the fact that we still had a lot of coal that we were burning. And so since then, really, we've kind of woken up and of course, over a lot of years, we've looked at a bunch of different things, but have realized that our main focus to make our campus better, both environmentally and financially, we feel, we needed to get off of coal. The honest truth is we are still working on that path. We still have a little bit of coal in our fuel mix at this point because we have not quite replaced the last of it with biomass. So really, we took a couple more steps back in 2010. We worked with our sustainability office and came up with goals around how much renewable fuel we would use on campus and how much renewable energy really overall. We set a goal for 40% renewable energy on campus by 2020. And we are now set to meet that by the end of this calendar year, I'm happy to say. So that's been very successful, and it gave us a catalyst to move beyond that first product, because the truth is we needed to find about double that first product in order to hit our 40% renewable goal. So we were kind of sitting around in 2007, 8, 9 thinking we were doing great, and really then needed to get to work in this past decade, and we have done that. So now as we pivot and look forward, we absolutely will replace the last of our coal. Our goal is to replace that last of our coal by 2025, another campus-wide goal that has backed us on that. And we will absolutely do that, hopefully in the next year. But then we will turn our focus to lowering our total carbon, right? So we've gotten rid of the coal, but now we still have natural gas, because at the University of Iowa, we will be, when we get off of coal completely, we will still be about half natural gas and half biomass. And so we still have a long path to go. And you know, it's a multiple effort strategy, like many have talked about throughout the conference so far, where we need to switch to electricity. So we're not using steam for some, you know, some uses to cut into that natural gas. But really, we're working now on goals for 2030 that will help us continue on that path. And it's been great that our administration has been supportive the whole way. And it all started back with a phone call back in 2003 to try to find a use for a product that had no home. So we're very excited, and there's a lot more to talk about, but I'll stop there and start taking some more questions.
So could I ask both of you to just speak a little bit to the feedstock? What are you using for biomass specifically? Where it comes from, and what's the technology that you're using to convert it to an energy, a usable energy resource? Bryan, want to start?
Sure, I can start. So our biomass gasification plant, just a little bit of background on it. So my predecessor looked around in about that same time, 2003, 4, 5. Remember when natural gas spiked and we used up triple the amount of energy that we would have used in natural gas in 1 year, and or cost, I should say, not actual product, but the cost. And so he said we have to think something differently, and we need to think about how do we provide some of the economic incentive that we're buying natural gas from a wellhead that's not in Minnesota. How do we provide that to local area folks? And so we are in corn and bean country, and so my predecessor said, why don't we look at using corn stover, right? So you'd use the whole corn stock. That was the start of the project. And the thing that we quickly learned during that project, we have a gasifier, was corn stover isn't dense enough. We had some problems with feeding and different things like that. Through the research, and again, this project, and Ben can attest to this probably, it was serial number 1, right? So that's why research universities do these things, is because we don't find the answers right away. We have to test some things. And so what we learned was that there was plenty of stover around. There's enough corn stalks and probably 10 miles from here to heat the campus for the year. The other thing is procuring was a little bit challenging. Farmers want the whole corn stalk to leave it in their field. They want the residual nutrients that are in that. And so that was another thing that we learned and kind of in the research. But the corn cob, which has little nutrient value, worked really well. So we moved to burning corn cobs. They're easy to handle, relatively dense. The one challenge that we had is in our plant design, agricultural materials have a significant amount of nutrients, minerals. And so the plant was designed with a wet scrubber. And when you put lots of minerals that replicate the same things that make concrete, guess what happens? It was really problematic with the wet scrubber to control emissions. So in the last few years, we have implemented a bag house, so a dry system. And so that's what we're just finalizing now, is some of the programming and some of the pieces to implement a dry system. And again, that's everybody who's worked on this project. So that's what you learn, right? That's what you learn as you go through these processes, is that there are things that you think will work really well, and you learn that there are some challenges. So so that's where I'll at, and if I can answer more questions. But.
Yeah, so at the University of Iowa, we now have multiple fuels that we are using. We started out with that industrial processing byproduct. It's the husk of an oat. So it's just the piece that's around the oat before you can eat the oatmeal that has to be removed. And so that's where we started. And then after that, we did a lot of trials. We burned wood chips for a number of years. We actually spent a lot of our time, and I made it sound like we were just sort of sitting back, not doing much in the 2005 to 2010 timeframe. Actually, during that time, we were investigating whether or not to install a boiler that would specifically burn biomass or a gasifier to specifically burn biomass. And one of our pivot points in our strategy really came when we decided that we had the people and the experience and the will to make biomass work in our boilers that were currently burning coal. And so in other words, we had sort of a financial chip that we could play with the campus administration, because we were saying, no, we are going to make these older boilers that could be retired. There were a lot of campuses retiring coal boilers at the time. We said, no, let us take even just a portion of that funding and see what we can do to make other biomasses work. So with a lot of trial and error wood chips, we tried more of the oat husks in another solid fuel boiler, just a lot of things that really didn't work very well, to be honest, for us. The main reason being that if the BTUs aren't high enough, if the energy content of the fuel is not high enough, we have to push so much through our system in order to get the energy needs that things became infeasible very quickly, right? So that is another pivot we made sort of in the early 2010s, 2012, 13, 14 range. We realized that we needed to find biomass fuels that had a higher BTU content. If we were going to reuse our old boilers, we needed the fuel to look more like a coal type product. And so we've been working on that. And that's actually where we're at now, is that we've worked with a company that has a product, and we will readily admit that it's not 100% renewable, but is about 90% renewable, because this company takes non-recyclable plastics and works that into a pellet that is a biomass-based pellet, but that has enough of this plastic that otherwise would go to a landfill. And they work that into the fuel, and that has become an excellent replacement for us for coal. And so that has become another kind of the other cornerstone of our biomass portfolio. I'll add one more, and that is that sort of on a leap of faith back then, also 2012, 13 timeframe, we realized we were going to need more feedstock. And we started to realize that pellets were going to be the way for our future. We also realized that in Iowa, we may not have all the feedstock that we want. And we really came up, and I love this idea. We have over 1,000 acres that we've rented from Iowa farmers, because over Iowa, there's corn and soybeans everywhere. We thought, this is the place where you grow things. Let's grow some fuel. And so we have over 1,000 acres of miscanthus grass planted right now that will become one of our main feedstocks. It is one of the feedstocks in our pellets, but we also intend that will continue to grow, and will be up to 20 or 30% of that pellet will be homegrown fuel. That the other aspect that we really like about it is the runoff. It really captures and helps waterways to become cleaner, because it's a fuel that we're growing that doesn't take any fertilizer products. It actually removes fertilizer products from the runoff that goes to rivers. And so that really is the summary of our three sort of big biomass is the oat husk, the pellets, and then we also have the miscanthus grass.
Erik, can I add just one? So our biomass gasifier, we're able to burn or to use wood chips as well. And so that's one of the things that we'll also be using is wood, or actually cattails and stuff like that. It's flexible. So we'll be testing some of those once we have everything back up and running and using.
So you both talked a lot about learning as you're doing. And I'm interested, it wasn't one of the questions I gave you beforehand, but could you talk about the relationship between the research and academic side of the university and sort of this more operational side of solving problems? What role did your researchers play in exploring some of these alternatives?
Go ahead, Ben.
Yeah, so at Iowa, we have worked some on specific fuels with researchers, although I would say we've really engaged the campus researchers and other departments sort of in some different ways a little bit. One of the ways that we've done that is obviously when I talk about the pellets, and they've got some of that plastic sort of sheeting plastic material in them. to be clear, that's one example of that is like an Avery label backing, to use a name brand, right? So you get the backing of those labels that can't be recycled. Well, one of the first questions that we really wanted to know is burning that material any better from an emission standpoint than burning coal, right? And so we have actually over the last 5+ years been working with our Department of Chemistry. And so we do regular stack testing. We did stack testing. We actually set up a trial, went back off of biomass and did a 100% coal run so that they could take stack samples and then have that to compare to a 100% pellet run on one of our boilers, an old 1974 Stoker boiler that we have converted and now runs 100% pellets. You know, we've now had 2 students get PhDs from analyzing those results and looking at over 100 different constituents, not just the ones that the DNR cares about here, but we're looking at all sorts of polycyclic aromatic hydrocarbons. They've done all kinds of research on that. And so that's one of the ways that we've been able to engage with folks on campus, not just to find a fuel, but also to help us make sure that the fuel we're choosing has cleaner emissions and gets us where we want to go. That's one example. The other example I'll go over real quick is same thing with those pellets. Obviously, we had a concern about what the perception may be in burning something like that. And so we engaged with our College of Business, and we had a couple of classes that took this on as a project and did some campus-wide surveys to find out what the atmosphere was on campus and what the tolerance may be for a product like that. And it was it was very enlightening because we thought that there would be major concern about switching to a fuel like this. And what we found out is that overwhelmingly, both students and faculty, number one, loved the idea that we were doing something to get off of coal. I get it, there's other options. We could have gone to all natural gas for that. But then they also really seem to like the idea that we're taking a product that would otherwise go to a landfill. And as long as we could keep our stack emissions cleaner than coal or any other, as clean as anything that we could burn, they were actually very in favor of doing something like that. So they liked that idea. And so we've used kind of both of those aspects to help us zero in on our strategy as we move forward. And so it hasn't been so much on the fuel research, it's been more on maybe the other sides of it to make sure that what we're doing is in line with what the campus would want.
In our demonstration project, we've had multiple different students and we've had researchers working on it, and we've received some grants from like the Minnesota Corn Growers Association, different things like that, to try to think about usability of different products. And I think one of the most interesting things is we've had some undergraduate students work on some of the economics of, as we were wrestling with the corn stove or corn cob kind of wood questions, what are some of the feasibilities? What are some of the other pieces that we need to consider? We had some projects where students did some of the offtake of, what about the nutrients that you take out of the soil if you take the whole corn stalk, different things like that. And so there was some really exciting opportunities for students to be able to kind of capture information and use that. And we're an institution, we don't have any graduate students, so we use our undergraduate students to help us kind of answer some of those questions, and some of the scientists that we had working on it as well, looking at, how do we, obviously the mechanical piece of it, but I think as Ben kind of touched on, a lot of the issues and questions were beyond technology. It was about perception and about economics and about kind of policy questions and different things like that. So which I think was a good demonstration for our students, because it's really easy to think about the mechanical things, but it's bigger than that for people to really think about. So
great. We have one question in the Q&A that talks a little bit about the cost of the biomass in comparison to your other fuel, and sort of how you're paying for that. And I think along the financial side, how have you financed these transitions and innovations? If you're just converting existing systems or constructing new ones?
When we started our project, we had 2 boilers that were 1968 models, and we had another boiler that was early 2000. So we needed to replace another boiler, and we still have the 1968 ones, but it was really to kind of replace and expand our capacity. And so we were able to, or my predecessor was able to secure a Department of Energy grant to be able to help do the research and some of the construction, and then also some state dollars and some research dollars from other entities to be able to do that. And then as far as so that was the capital cost to build the project. But then as far as on the operational side, we purchased fuel by the ton. And so when we were working with some of the local area farmers, it's been a few years since we've done that. And so we will have to restart that market and think a little bit about that. Since we're able to use wood, waste wood and different things like that, that's relatively easy to procure. The challenge, and I'll be completely honest, I think it's one of the things that everybody is dealing with, is natural gas is really inexpensive right now. And so that is a challenge. One of the things that we think about, and one of the kind of impetus behind why we did this as well, is we sit in an area where we can be curtailed, because if the natural gas pipeline can't handle demands from other areas, for us to have a lower purchase price, we obviously we take the ability for them to provide some demand control. And so that costs us a lot of money if we do that, because we need to switch to fuel oil or other things that have a really high carbon impact, but also have a high cost impact. And so was the other kind of, we wanted to spread some economic dollars in this area. We wanted to think of a way to provide kind of a carbon neutral source for thermal, but then also we needed how do you protect ourselves? And when it's, unfortunately, Minnesota, when it's 20 below for a week, how do you protect yourself against that huge cost that will come when it's that kind of temperature?
So I'll start to talk. At Iowa, the financial discussion almost always comes back to the rates that we charge our customers. And so I know many universities are set up this way, but we are essentially a nonprofit where we set a rate. I've tried to smooth that out where we set a rate every few years rather than change the rate every year. But in the end, if our fuel prices go up or down, it really, that savings or that cost gets passed on to all of the different departments around campus. And so if there's an increased cost for fuels, I have to be able to justify that to all of the deans and department heads around campus. And so really, even back in 2003, our outlook on what to do with biomass fuels has always been that we need to focus on fuels that will not cost the campus more than staying on the current path, right? So essentially, we wanted to not have to raise rates in order to pay for a switch to biomass. And we've been very lucky that we've been able to find fuels that have fit that. And one of the good things about that is I do think that also helped us very quickly narrow down the list of fuels that were options for us. Talking about things like wood chips, we did wood chips for a while, but in order to continue and to scale that for us, we would have needed to bring in over 100,000 tons a year of wood chips. That just becomes not feasible anymore, and the cost goes up and up as you do that. And so it really helped us land on this alternate fuel that really has fit, because although I get it, it's not perfect. We all get that. But the price is right in line with what we had previously been paying for coal. And so really it's a very easy transition for me when it comes to a financial discussion, because I don't have to go to a department head and let them know that their utility bill is going to be higher next year. And we plan to continue that. As we look at electrification, which has been a discussion topic through most of the sessions so far, we're looking at that too, but we're going to keep that same mindset as we look at electrification, because it's really hard for me to justify to a researcher that they should take some of their budget or more of their budget than they were before and hand that over to utilities versus doing the great work that they're doing in their research department. So we are going to maintain that as long as we can. It may be the time may come that we need to change that outlook, but our goal is, and our plan is, to maintain this transition without raising our utility rates to our customers. And the fuels that I'm talking about are all able to do that. I would say Miscanthus is still a little early on. We are trying to figure out how to get better at harvesting and getting that product into the fuel and into the boilers. But I have no doubt that the targets we've set for making that product financially viable, we'll keep working on it. And with good targets and good goals, you kind of give everybody the direction and say, here you go, this is what we've got to figure out. And we've got good teams that have been able to do that. We've proven over the last 17 years, we've been able to take some leaps of faith. And with the group that we have on staff, we've been able to figure out how to make it work and to make it financially viable.
Excellent. Could you discuss a little bit, you sort of alluded to some of these, the co-benefits of using biomass to the campus and beyond the campus? What kinds of positive outcomes have you seen in the community and on campus as you've shifted where you're getting your fuel from, essentially?
Yeah, so on this one, at Iowa, we have, obviously we're still burning coal, and that's not a good thing. And we are really working as hard as we can to get off of coal. I do think that the work that we've done, and when you look at the progress we've made, and between the different biomasses, we're using almost 80,000 tons a year of biomass right now, right? I mean, that is a lot of renewable energy that's being used. I do think that we've seen that most folks around our immediate area on campus, they get the idea that we didn't want to shut down our coal boilers and just go straight to natural gas. Not that there aren't options, but the University of Iowa uses so much steam that to find some other option, if we went down that path, would have probably locked us in to using non-renewable, using fossil fuels for possibly a longer period than we will right now. So I think, although we have clearly not been perfect, we've seen that the community and those who want to engage with us have been very supportive of the path that we've gone down. I get it that there's a lot of impatience that we have not moved as quickly as maybe we could have, or they think we should have. But at the same time, we have to remember that we've got one of the largest hospitals in the Midwest on our campus, and reliability has to be a top priority. We can't just switch fuels and lose our reliability. And I do think people get that too. So, I do think those conversations with folks around town have been excellent, both on campus and off campus. I will add one more side benefit that I think has been just wonderful for our program. And that is when we go out to recruit staff, whether it's an engineer on staff, operators, plant managers, what have you, there are a lot of people out there, of course, who are looking for more than just a job. And the fact that we get respondents to job postings who, will gladly take whatever job they can get because they love the work that we're doing, they believe in what we're doing. We have been able to build some incredible teams because we've got people who wanted to come work at the University of Iowa because they've heard of our biomass program. And that still continues. We hear that all the time. And the thing that I've noticed from that then is we get really high caliber people on our team. That translates to, we've been able to do planning and scheduling work. We've been able to do our, it makes every other aspect of our department run better. And I think we have found savings and found efficiencies because we've got those great people on staff that aren't related to biomass, but we got them on board because of the biomass. So it has really helped us build some really top-notch teams because we find people are interested in working in a place that's doing this kind of thing.
So yeah, I think for us, and Benda did a really good job of, I think, kind of summarizing some of the things for us. Again, thinking about where do we invest our dollars? We're have a significant purchase when you think about how much energy you buy in a year, and how do we think about keeping those dollars locally, right, instead of sending them out somewhere else. And so one of the things that our biomass program was one thing that kind of started some of this, and what we have worked on at the university is we have a program called the Morris Model. And so we've been working with the city, the hospital in town, other nonprofits, the county. Also, the University of Minnesota has a West Central Research and Outreach Lab in Morris, and then the USDA has a soils lab in Morris. And so we've been working through that program. And I think so some of the renewable energy things and the biomass projects that we have started here has allowed us to be able to kind of expand that into the community and be able to think about. We did a kind of, I would say, somewhat research study about how much how much energy is purchased in the county. And so it's we looked at electricity, natural gas, all of those that are purchased in the county, and said, okay, we're spending, I think the county's spending like $15 million a year on energy, right? And so you're like, what if some of that, 50%, 60% of that stayed in the county? Think of the economic benefits that there would be in the county, both on the electricity side and the renewable energy side. If we're able to use, so if we're using corn for ethanol, could we use the cob for biomass? And all of a sudden that the farmer is generating even $5, $10, $15 more an acre, that's money that's going to end up back in the community. And I think that's where we were able to kind of think about how we wanted to do projects that helped advance that, right? It's really easy to buy natural gas. It's all the infrastructure's there. It's really easy to buy. We don't have coal burners, but I know it is. This infrastructure's there. It's harder to create a market, and that's what we've done as entities in Minnesota. The ethanol market was created. Some of these things are you create the infrastructure and it gets more efficient, right? I mean, and that's part of the process. And so for us to be able to, our goal was to help think about that. How do we demonstrate that? Our campus is 2,000 people with employees and students and different things like that. And so we looked at, if there are how many towns across the country that are 2,000 people or less, and could this become a model for people to be able to help develop? You'd need a couple wind turbines, and you do some things with centralized heating, and you could make yourself energy efficient and carbon neutral, and hopefully keep some of their dollars in your community. So that's the kind of the secondary benefit of the things that we were thinking about. And I agree, Ben did a really nice job of talking about. It also attracts people, right, who want to do something bigger than themselves. So their job might be not related to it at all. And we've definitely had faculty members who've come here because they're like, I want to be connected to students who are thinking about these things, even if I do a tangential project related to any of the work that's happening. I can say that I'm part of what's happening and where we're going. So.
Yeah, I think that's really exciting. And for other universities maybe listening in, I don't know if you guys have ever used this argument, but if you need appropriations and you need to go to the state, and that argument of, well, we can send $20 million out of state to a coal mine or coal company, or we can try to invest that locally. That I don't know if that leverages any goodwill towards an appropriation for upgrades or the technology needed. And we did have a couple questions about for the Morris campus, the decision to move to biomass gasification versus combustion. Was that primarily because of your existing systems and compatibility?
It's a really good question. And at the time, we put an RFP for different designs to be able to, and I think the design that came forward was around combustion. We added a new boiler, and so we used the synthetic gas that came off of that. The other part, and I wasn't in this role at the time, but I think the other part that was to be considered was the ability to pipe that into the other boilers that we already had. So if you were in a synthetic gas, it would be easier to be able to move it and transfer it than just having it be a combustion. So.
And if I could add on that quickly, because we at the University of Iowa, we did look at gasification for a number of years, and even kind of got some designs that we went down the path on a little bit. In the end, the reason we didn't go with gasification was that the size of gasifier we would need, one that could essentially put out 200,000 pounds an hour of steam, or between 150 to 200,000 pounds an hour of steam, just is not common enough. We felt not really enough of an industry standard. And so after we looked at all of that, that's when we sort of decided to circle back and say, let's take an old 1974 stoker boiler and a 1995 circulating fluidized bed boiler and make those work on biomass, because the truth is, you know, we can keep those boilers going for quite a while. And as we transition, we don't know what the future will be. And so we ended up, again, going the route to opt not to even do an investment in solid fuel. We did put in a natural gas boiler recently because of campus load growth. But I do honestly hope that that's the last boiler that we have to install. And I do hope that as we make more of a transition and our steam load starts to drop over the next 10 years, that I'm actually able to take an old gas boiler offline and keep our percent renewable higher that way.
And we had one other question about any safety or reliability issues with the gasification plant.
I think that's one of the things that you have to go in with eyes wide open. It is more challenging. It takes more people power, more labor. Safety and safety. We haven't. The design was good. I think we were that piece, but it is something you have to consider. We did have to, and one of the pieces, again, learning all of this, we did have to put in a natural gas overfire, just because when you have different materials coming in there, even with wood, when we were running that, because our demand for steam is a lot less than where Ben is at. We had to put in something that could kind of help manage the variability, right? So when it's 20 below, it's easy, right? It's all, it's open, right? You're just going. But when it's 55 during the day and 35 at night, that's tough, right? Or when it's 75 during the day, as we're starting to see now in these shoulder seasons, you go from 75 to 40, right? I mean, that's you don't have a lot of place to take the load, and so we've needed to kind of have that ability to flex a little bit more, and that to be honest, that's challenging on any kind of solid fuel, right? And so reliability, when we're running, it's fine. It's just we've needed to think about that, because you need to pull back during the day, and unfortunately with this in Minnesota now, sometimes you have to turn the chillers back on in the middle of the day, because and then make to try to make up the difference, because the temperature has changed so much during the day. So.
And at Morris, are you also producing electricity from that as well? You said?
Yes. Yep. We have. Thank you. We have a back pressure steam turbine. So we make high pressure with the boiler, and then the variation, we take that to make we have a 300 kW back pressure steam turbine. When we're running it, usually it's about 175, 180 that it produces. So that is really beneficial for us in the fact that it produces at typically times that our wind turbine might not be as producing as much. And so basically the amount of load basically takes care of the heating plant and anything that we need to use for energy at that point. So.
Fantastic. Let me just see if there's any other questions in the chat or in the Q&A. Well, I really appreciate your insights on the challenges, the bumpy road. Clearly, it's not plug and play like a natural gas facility might be, but it, I think, shares a lot of lessons for how universities might be able to integrate biomass more successfully. So we'd like to thank you very, very much for joining our session on biomass. And one of our engineering professors who's working on projects here just said she has a ton of questions, who's also an Iowa native. And I'd just like to remind people that we will have a breakout discussion for our networking session for the next half an hour. And Kate just pasted that link into the chat, so you all can grab that. So we'd love to continue these conversations in the next networking session. So again, Bryan, Ben, thank you very much for joining us. It's been really, really interesting.
Thank you for having us.
Thank you for having us. I think it's an exciting topic, and it is truly, it's a bumpy road. So there's nothing smooth about it.
Great. Thank you all.